Hello, discrete math fans. Let's talk about strings. Now, if you've done computer programming, you have a sense of what a string is. It's just a collection of characters. Those characters are often letters, but they don't have to be. You're going to put them together, and you're going to form words, essentially. So strings are kind of like words. A word is an example of a string, but not all strings are words. There's always a set of characters, which we're going to call an alphabet. So let's make a definition of what we mean by strings. So we're going to let S be a finite set with at least one element, and that's going to be called our alphabet. So a string over S is a finite sequence of elements from S. Those elements in S are called characters of the string, and the length of a string is the number of characters it contains. Now you can have a null string. That's a string with no characters. We're going to denote that with an epsilon. We're going to say it has length 0. Real words, you don't have anything like that. There's no word that has no characters, so this is more of a technical definition for the mathematics. Now we'll typically define an alphabet for use with a problem. For example, we might just take an abbreviated alphabet and just take two letters, A and B. And we'll actually do this more often than you might think. So the set L, that are the set of strings over S, include things like AA, BB, AA, maybe a string with 7 A's in it, or AB, AB, or just A. Epsilon is also a string. That's our empty string. All right, there's a standard operation on strings. It's called concatenation. And all you do is just glue the two strings together. So as an example, if S is equal to AB, AB, AA, and T is equal to BBA, then by gluing them together, it goes, S goes first and then T, then we get AB, AB, AA, BBA. We could concatenate S with the empty string, but then we don't get anything new. So S concatenated with epsilon is equal to S, and so that's just AB, AB, AA. So that concatenation, you write it in such a way that it looks like you're doing multiplication, but we're not multiplying. It's a concatenation. All right, let's make a function that involves strings. So we'll use the same alphabet as before. That's just got two letters in it, A and B. We'll define a function from L to L. Remember that L is the set of all strings. They are finite strings, and L includes the empty string. So if S is a string in L, then f of S is equal to AS. So that means we're concatenating A at the front of S. Now we could ask, what is the domain and range of F? Well, the domain of F is just the set of all finite strings. That's L. You're allowed to plug in any string into this function. The range is the set of all strings that start with an A. Whatever you get as an output has to have an A in front, and any possible string that has an A in the front would be an output. Okay, that's all for now.